King Tut, learn it.
Hello, everybody. This is King Tut here, and welcome to your second Electronics 101 tutorial. In this tutorial, I'm going to talk to you about basics of electricity. Before we go in, I'm the basics of electricity I'm going to teach you about. It's going to be all watered down. It's not going to be deeper in physics and equations and stuff like that. The goal of the series here is to have you guys build electronics and design what you want for electronics. Some of these equations are helpful or really necessary, but not all equations in this series are useful. It could be useful for uh, what you want it to do in different types of speciality, such as digital signal processing, such as semiconductor, such as chip designing, which is part of semiconductor. So in the basis of electricity, it's going to be all watered down because the main goal here is to get you guys building circuits and understanding how electricity works, not the whole deeper theory behind it. So before we explain about electricity, we want to know that everything that we live is made up of atoms. And without atoms, we wouldn't even exist. So what makes up atoms? It's made up of protons and neutrons, which together they form the nucleus. And then the ones orbiting around it are electrons. Protons has positive charge, and electrons have negative charge. So what does that have to do with electricity? Well, these are really important because atoms are used and abused by scientists, by chemists, by electrical engineers when they're doing chip design, by civil engineers when they're doing mechanics of material, mechanical engineers for same reason or for other things. And mostly it's all about making materials so that when we put in electricity in it, it works like we expected. So different types of fields use and abuse atoms. If you're outside of the engineering field or chemist or any science field, you're not going to be using and abusing atoms. You're just going to be, if you're humanity, you're going to be using and abusing books and analyzing it. And if you're into business, you're going to be using and abusing money and advertisements and so on and so forth in business. But anyway, charge attracts when these two charges are different. So if there's a positive charge and there's a negative charge next to it, it's going to attract. And two or more of the same charge are going to repel. So two positive charge are going to repel, and two negative charge next to each other, it's going to repel. Sorry about that. Are going to repel. So, for example, if you're going to rub a balloon on your thigh or on your arm and put it on your hair, it's going to stick because you literally rubbed the positive charge off the balloon. So all it has is negative charge, and you and your hair has positive charge. So when you put the balloon in your hair, these two charge attracts, and the balloon sticks in your head. But what if you put it closely to your hair? Well, your hair sticks out and it goes towards the balloon. And that's again because these two charge are attracted to each other. The balloon has negative charge and your hair has positive charge. So of course they're gonna attract. It's kind of like magnets. If if you have the north and the south, uh, two two polar two similar polar are gonna repel. But if you put two magnets of the polar opposites, it's gonna attract. So that's what. So if you don't understand charge, it think about magnets. And this phenomenon is called static electricity. So when we go into what I call a dynamic electricity, or electricity flowing in materials, in wires, and through different components and circuit, I'm going to show you how it works. So there are types of material that we use for electronics. So there's conductor, which allows electricity to roam and flow freely in. And examples of conductors are aluminum, steel, gold, copper, and silver. Insulator are the literally the opposite of a conductor. Electricity cannot roam freely in an insulating object. So let's take rubber for example. If you try to put electricity into rubber, it's not gonna flow into rubber freely. So examples of insulator other than rubber are plastic and wood. And you guys might think that wood is conductive, which is not. The the only way you might think it's conductive is since trees absorb water and sunlight, the electricity roams freely into water. Water is conductive, and the tree is alive. But even though trees are alive, if a lightning hits to the tree, it's going to cause wildfire. So, most likely, if you put so much electricity into insulators, you're going to end up burning it. That's all. Or melting it. If you put a lot of electricity to plastic, you're going to end up melting it. Semiconductor is a half conductor and a half insulator. Most people, most electrical engineer will call it a bad conductor. That's because it's not fully a conductor, it's a semiconductor. If you look at the word itself, semi means half. And conductor means like electricity, materials that electricity could roam freely in. So it's half of the electricity that could roam freely. And it's applied to different components, such as transistors and diodes, which I'll get into it in future tutorials. An example of semiconductor material that is being used is silicon. Most people, actually, most materials, most components use silicon. The only up and rising material is graphene. So hopefully this video is helpful. Thank you so much for watching. If you really like my video, please give it a big thumbs up. If you're on YouTube, BitChute, or BitTube, please subscribe to my channel. If you're on Vlare, please follow my channel. If you're on Library, please follow my channel and download my video. And I hope to see you in the next tutorial. Bye!